What up, geometry peeps? We're going to continue in the unit on similarity, and today we will begin tackling proving triangles similar. So what we're going to do is talk about similar triangles. Now this lesson has a few things, so again I'm going to cut it down. I'm going to try and make 3 different videos for this. This is part 1. We're going to talk about the angle-angle postulate in this particular lesson, and we'll talk about some other things with similar triangles. But we will eventually learn about all this neat stuff when it comes to triangle similarity. Now, I know you might be looking at the title, Proving Triangles Similar, and it might be a little bit scary, but it'll be okay. And we'll start with notes. Notes. There is a postulate, or 3, for triangle similarity. And the first one we're going to talk about, and that's what will be the focus of today's video, is angle-angle similarity. The way this works, if you have 2 angles of one triangle, and they are congruent to 2 angles of another triangle, then the triangles are indeed similar. Okay, so angle-angle, all you need is 2 angles to be congruent, then you'll have similar triangles. Because clearly, if the 2 angles are similar, then the third one has to be, or 2 angles are congruent, the third one has to be. But what does that mean for the triangles themselves? They are similar, meaning, again, same shape. So we have that similarity postulate. What a cool word. Anyway, moving on. Let's do some examples. So here's an example of angle-angle similarity. Are the 2 triangles similar? How do we know? So we have triangle RSW. And notice how RSW goes this way. RSW. And then triangle VSB. Look at this triangle, VSB. Are they similar? How do we know? So clearly we can see, well, we have the 45-degree angles. That's totally congruent. But we need 2 angles to have angle-angle similarity. Are there any other congruent angles? And you should be thinking, cats, yes! Vertical angles, bruh! I know. So vertical angles are congruent. And if vertical angles are congruent, then we have 2 congruent angles per triangle, which leaves us similar triangles. So yes, they are. We have angle-angle similarity. Okay, so that's what we look for. Now, I will warn you, correspondence is going to become very, very important. So notice how angle R corresponds to angle V, and angle S, of course, corresponds to angle S. And that's going to become important right about meow. So correspondence can become important, and here's an example of why. Are these 2 triangles congruent? How do we know? Well, as you can see here, we have triangle JKL, which goes this way, and then triangle PQR, which goes this way. Remember, order matters. Order matters. So are they similar? Well, take a look here. We've got 70 and 70, and we know that L and R, of course, L and R, they are corresponding. So we're looking pretty good, right? But then we have J at 30 degrees and angle Q at 85 degrees. Well, that's not telling me because J corresponds with P. We don't know angle P. And Q corresponds with K, and we don't know angle K. So what the heck? We have to then use some of our triangle properties to figure out what's going on. So the first thing we'll figure out, because I happen to have my pen here, we're going to figure out angle P. How's that work? Well, we have 70 and 85. 70 and 85, of course, is 155. What does that leave for angle P? Well, that means angle P is 180 minus 155. And then we do some subtraction with regrouping. And we find out that angle P is 25 degrees. Okay, so angle P is 25 degrees. Wait a minute. If angle P is 25 degrees and angle J is 30 degrees, well, that's not congruent. Perhaps angle K to angle Q will help alleviate some stress. Well, now let's look at angle K, because why not? Angle K here. So we have 30 degrees with angle J, 70 degrees for angle L. 30 and 70 is 100. And if we subtract 180 minus 100, we find out that angle K is 80 degrees. So angle K is 80 degrees, but angle Q is 85 degrees. So we only have one congruent angle, and that's not enough for angle-angle similarity. So no, one angle won't do, right? So we can't say that these are similar. So no, we can't, okay? Okay. Next example, are these two triangles similar? How do we know? All right, so this one's kind of interesting because I'm going to just take time to talk about correspondence. Do these triangles correspond to one another? Well, let's see how. Clearly, angle F and angle C might be corresponding. We don't know, but angle B and angle D are. Okay, so these are definitely corresponding. The only thing that's missing, do we know what angle C is, and do we know what angle E is? Because they don't look quite corresponding, do they? I don't know. So how are we going to figure this out? Well, let's find our missing angles. In the first triangle with A, B, C, if we have 39 here, we have 90 here, don't forget, right angle is 90, that gives us 129 total degrees. And if we subtract that from 180, we will find that our missing angle is 51 degrees, right? Holy cow, all of a sudden, hey, wait a minute. If this is 51, and this is 39, and this is 90, and this is 51, and this is 90, guess what? Angle E must be 39 degrees, okay? So now we know if all three angles are congruent, which means that two of them are congruent, which means, yes, they are indeed similar. Yes, all angles are indeed congruent, but we only need two. All angles are congruent, but in reality we only need two. So let's talk about correspondence real quick. I'm going to redraw triangle ABC. Do you mind? I hope you don't. Our right angle is angle B, so I'll make A up here and I'll make C down here. What if I redraw triangle, if I said ABC, what if I redraw FDE, let's say? I will know that D is my right angle here. So D totally corresponds with B. Which angles correspond, right? So notice how A was 39 degrees. That means, am I putting F or E where? Right? If A is 39 degrees and A is up here, then E must be up here. So if I'm going to call this triangle ABC, I must call this triangle EDF. Okay, so we have to be very careful with correspondence. So triangle ABC is, of course, similar to triangle EDF. So we have to be very, very careful with correspondence. Okay, moving on to your favorite and mine, proofs. Oh, it's okay. It'll be fine. Just relax. So now we're going to prove triangles similar. We have given statements. Segment FG and segment GH are congruent. Segment JK and segment KL are congruent. And angle F is congruent to angle J. We're going to prove that these two triangles are similar. Now, how's that going to work? We're going to prove angle-angle similarity. But before we go into the proof and the statements and reasons, I want you to see if you can guess what is the hook, right? What's the major thing? It's almost like slamming domino down, like you're playing dominoes. What's going to be the last thing? Like, bam! You know I'm right. What do you think we're going to be using to know we're right? Hopefully, you can see right now we are dealing with isosceles triangles. And if you can tell that we're dealing with isosceles triangles, we will know that this angle is congruent to this angle because this side is congruent to this side, and this angle is congruent to this angle because this side is congruent to this side. So all the angles are congruent. Angle similarity, we're going to have that, right? So hopefully you can see, without even doing much work, the answer is going to be yes, we know these are true, and here's how. Because they're isosceles, because two congruent sides means the opposite angles are congruent. Angle similarity. Right? So that's the hook, right? Bam, we know that. So how is this going to look for the proof? First thing we do is establish our given statements, right? We know that. FG is congruent to GH, JK is congruent to KL, that's given, right? And now what we start doing is the hook. The triangles are isosceles triangles. How do we know? Because that's the definition of an isosceles triangle. If you have two congruent sides, you have an isosceles triangle. And when we say FG is congruent to GH, blam, isosceles. And when we say JK is congruent to KL, blam, isosceles. And so we establish that. Now we can talk about the angles being congruent Because that's the definition of isosceles triangles. The base angles are congruent. So we can now say angle F is congruent to angle H, which is what we established here. And then angle J is congruent to angle L, which is what we established here. And that is the base angles are congruent. And now we just tie in our last given statement. So notice how we saved the last given statement for last, because once we know that F and J are congruent and H and L are congruent, everything is congruent to each other. What property is that? Transitive property. Okay, so we know that F and J are congruent and H and L are congruent, and this establishes corresponding congruent angles. Okay, so that's what this is establishing, and we need to know that. Okay, so corresponding congruent angles. And then we can say, boom, they are congruent due to the angle-angle postulate. Okay, so that's how that one works. And if that was confusing, rewind, try it again. Let's do another one. So here's another proof. I know, proofs, no. So this is the last one. Given that MP, segment MP, which is here, is parallel to segment AC, how can we prove these two triangles congruent? There's a bunch of different ways we can take this. First thing we can do is talk about, well, come on, vertical angles. We can do that, right? We can do that. But believe it or not, this proof will not include vertical angles, because, check it out, if, I'll use the inline arrows, if AC and PM are parallel, guess what we are looking at? If I look at it this way, you probably have an easier time seeing. We're looking at two parallel lines cut by a transversal, thus giving us alternate interior angles. Okay, and hopefully that didn't hurt your head right there. Hopefully you would see that. So we can prove these angles are congruent to each other because of parallel lines, because of alternate interior angles. So we're not even going to need vertical angles, right? You might be thinking vertical angles, but we don't even need it because a parallel gives us other two immediately. Ah, awesome stuff. So how's that proof going to work? Boom. We start with our given statement. They're parallel. And then what? We establish our alternate interior angles right away. And then we're done. Okay, so if lines are parallel, alternate interior angles are congruent. We have our two congruent angles, and we can sign, seal, deliver this proof with angle-angle similarity. All right, so that's how angle-angle similarity works anyway in triangles. And hopefully you learned a little bit about some stuff. So today we talked about angle-angle postulate and some proofs. We will continue in further videos with other things. Take care.